In this video, we are going to talk through the Module 1 review questions. Module 1 is over functions. So in question 1, we're given two different functions, f of x and g of x, and we're going to find the following. Question A says to find g of negative 4. That means that we're going to take negative 4, and for every x that we see in the g function, we're going to replace it with a negative 4. I'm going to put it in parentheses when I plug it in. And then we're going to evaluate it. Negative 4 squared is positive 16 plus 20 gives me 36. Most of the time, if I put in a number, I should get a number in return. The setup for B is a little bit different. They tell me to find x if f of x equals 7. As soon as I see this equal sign in the problem, that tells me it's a solving problem. So I'm going to set the number they give me equal to the function. And we're going to solve for x. To do that, I would subtract 3. And finally divide over by negative 2. And we get x equals negative 2. And finally, the final problem of question 1 is function composition. So that's a function within a function. So we're going to start from the inside and work our way outside. If we know that f of x is equal to negative 2x plus 3, that's what we're finding, g of negative 2x plus 3. So that means then for every x in the g function, we're going to plug in negative 2x plus 3. If I have this binomial squared, I have to write it twice. I cannot just square both terms. At the same time, I'm going to distribute this negative 5. And then we're going to FOIL that out. In total, once we FOIL it, we should get 4x squared minus 12x plus 9. And then I'm going to bring everything else down. If you're unsure of how I did that, think back to all the times we drew over those arrows and so on. So we're going to have 4x squared. We have to combine like terms, so minus 2x minus 6 as our final answer. In question 2, we're going to go through key features of the quadratic graph on the left. We have gone through key features in almost every module that we've done, so a lot of these terms should be very familiar. Domain represents all of the possible x values of a function. So for the quadratic on the left, our domain would be negative infinity to infinity. Range represents all of the possible y values. So we're going to start at negative infinity because those arrows are going to keep getting lower and lower. And it can go up to 8. That's our tallest y value. On the 8, we put a bracket. We have two x-intercepts on this graph. They are located at negative 3, 0 and 1, 0. Our one y-intercept is located here at 0, 6. So x-intercept spots where the graph touches the x-axis, y-intercept spots where the graph touches the y. For increasing and decreasing, I'm going to draw a line through every change of direction that I see. In increasing and decreasing, we only care about the x values. So I can see that my graph is going up on the left half and down on the right. Sometimes you'll have more than one or more than two sections of your graph, depending on what it looks like. So I know my graph is increasing from negative infinity to negative 1. And I know it's decreasing from negative 1 to infinity. End behavior describes what's happening at the endpoints. As x approaches infinity means I look at the right side's going down. As x approaches negative infinity, that means what happens on the left side. My left side is also going down. My vertex represents either that minimum or maximum point of my quadratic. In this case, the vertex is negative 1, 8. Axis of symmetry always starts with x equals, and then whatever we filled in for the x value of the vertex is what we fill in for axis of symmetry. And finally, question number 3 from Module A talks about the transformations that are applied to the following functions. So we have 4 main transformations that we looked for. We looked for reflections, stretches or compressions, horizontal, and then vertical translations. So in question A, I'm going to list them out in order, the transformations that are applied to that function, and talk about why they are the way that they are. So the first one that I see is this x minus 6 in the parentheses. So inside moves my function left to right. So that negative 6 on the inside moves my function 6 units right. Again, that is our horizontal translation. The next thing that I see is this negative sign in front. That negative is a reflection over the x-axis. And finally, I see a positive 1 at the end. That is a vertical translation, and that is always the same as the number tells us. So that would be 1 unit up. Question B, I have a 1/2 in front. That is a vertical compression. When I think about the differences between a vertical compression and a vertical stretch would be, this one is a fraction between 0 and 1. The next thing that I see on the inside is that positive 1. That is our horizontal translation. Inside we go opposite, outside we go same. That moves my function 1 unit to the left. And finally, we see a minus 4 at the end. That is our vertical translation. That moves my function 4 units down. And finally, on question C, again, I see that negative in front. That is a reflection over the x-axis. I also see a 3. That is a vertical stretch by a factor of 3. Note that the negative and the 3 do 2 different things to my function. And finally, I see that plus 5 at the end. That would be a vertical translation, 5 units up. Biggest key here is to remember that inside is opposite, outside is same.